other time.
Hello and welcome to the Weekly Space Hangout for a Wednesday, November 21st, 2018. I'm Morgan Renberg. Wait a minute.
Wait a minute.
Nobody updated this week. I'm Fraser Kane, publisher of Universe Today. This week, we're going to be talking about the Mars 2020 landing site has been chosen. Type 1c supernova, what came before, the exocup, the sun-sibling star, and water detected on an exoplanet. Joining me this week, we've got whoever's on my screen. It happens to be Morgan Renberg. Morgan.
I'm here.
Hello. It. And congratulations last week. You did a great job, is the word on the street. I haven't listened to last week's episode yet.
I survived.
A huge thank you, though, Morgan, for hosting again, now on your own. Although I guess you had Pamela Engineering and you were hosting. So
we did it.
You did it. And I know people enjoyed it. So congratulations. And this means I get to go on more vacations. I can't wait. All right. Next up, we've got Kimberly Cartier. Kimberly.
Hey, Fraser. Happy podcast day.
Woo!
And yes, we did survive. Morgan did a great job. But please don't leave us all the time.
I won't leave you for another 3 weeks, and then I might have to leave again. But then I'll be back. Anyway. And then not till March, until Paul and... Yeah, you got 2 weeks. And then until Paul and I go to Costa Rica, which everyone should come. No one's going to watch the show because they'll all be with us in Costa Rica.
That's right.
No one's going to watch Morgan and I?
On the Astro Tours. No, they'll all be with us. I mean, we'll all huddle around and watch you guys from afar, but no, we're all going to be in Costa Rica. All the Weekly Space Hangout fans. All right, and who's on my screen right now? Paul Sutter.
Hey, everyone. And yes, Morgan did a fantastic job last week.
I like the permanent place the book has beside you there.
Oh, this? I didn't even notice it. Wow. Yes. Oh, yeah, my book is here.
I've been quite impressed at already the various media engagements that I've heard you on. The Starts with a Bang podcast with John Michael Gaudier. You're everywhere, man.
I'm doing it. I have a very good publicist.
Oh, that's a thing.
That's the secret.
That's the secret.
Yes.
All right. And last but not least, we've got Bruce Betts from the Planetary Society. Bruce, welcome to the Weekly Space Hangout.
Hello. Good to be here. Thanks for inviting me.
Oh, this is awesome. Man, I got so many questions for you. So many things to talk about. And before we do that, we've got a little bit of work that we've got to do here. So first up, I want to give a big thank you to our good friends, of course, at the Weekly Space Hangout crew. They are the producers. They are the glue that holds us all together and helps organize all of the guests. For example, the fact that Bruce Betts is here. I had no hand in this. I didn't even recommend it. I didn't even know how it happened, and here he is. I'm as surprised as you.
You would have rejected it. If
I had any opportunity to. No, are you kidding me?
Thank you to the crew.
I'm super excited to talk to Bruce. But we also have another book giveaway. So believe it or not, the WSH crew is doing a third book giveaway. This time they're giving away 3 copies of Mission Moon 3D. I've got the book, A New Perspective on the Space Race by David Eicher, and Dr. Brian May, who someday will get on our show. So you can win a copy of this book. Go to send an email to giveaways@wshcrew.space with the subject 3D. Be sure to include your name, email address in the body of your message so the crew can contact the winners afterward. To be eligible, your entry must be postmarked by email no later than 11:59 p.m. Eastern Time on Tuesday, November 27th. So you got another week. And then David Eicher will be our guest on the Weekly Space Hangout next week. We will be selecting 3 winners at random from all the eligible entries received. No purchase necessary. You don't need to be watching the show live. You can live anywhere on the planet. But only 1 entry per person. So go to the Weekly Space Hangout crew to learn out more about this. wshcrew.space. All right, Larry Beckham says, we will moon you. All right, let's move on to the interview portion of this episode. Bruce, who are you? What do you do?
I am the chief scientist of the Planetary Society, and as of recently, an author of a book, Astronomy for Kids. And I'm also the program manager for our LightSail project, trying to fly a spacecraft that has a solar sail for propulsion.
Uh,
I have many other things. I have giant dogs and sons as well, but I will skip that part.
a regular contributor to Planetary Radio, and able to say random space fact in an echoey voice. All right, let's talk about the book. Congratulations! Apparently, we're all writing books these days. What is your book?
Peer pressure.
Yeah.
Everyone's doing it. It is Astronomy for Kids: How to Explore Outer Space with Binoculars or a Telescope or even just your eyes. So it's an introductory book to night sky astronomy, basically, and it's titled Astronomy for Kids. But I think it's also good for anyone just looking to first get into recognizing what's up there. It talks about constellations and how to use telescopes and what to use binoculars for, and has sky charts to help you find things easily. And it's kind of a first step where they then can move on to books like the one you've just produced, Fraser, with more advanced information.
So what? I mean, I guess when you're looking to get your kids into astronomy, what is the way that's going to hook them? What's the way to really sort of get them involved and interested?
Well, I think it of course depends on the kid, but
Yeah.
there are a couple paths that one of which I think my book is designed to help with, which is explaining the basics of what you're seeing in the sky and changes with during the night and season, and being able to look up and say, hey, that W-shaped thing is called Cassiopeia, and hey, this is how you find the North Star, or I've got binoculars, what can I look at? I think, and maybe it's just based on personal experience, going all the way back those many years to when I was a kid. Pretty pictures from planets and telescopes, and getting interested in the exotic, weird worlds and places out there.
Yeah, I think for me, that's what it was. There was this book called Our Universe. I'm sure you probably remember. There's like the Time Life book called Our Universe. It had this really cool spaceship on the front.
I've
And
got it on my shelf.
do you really? I've got to buy one. I haven't had one for a long time, and I really need to pick one up. Have you got the original version or the re-release that has?
I've got a really old version.
Yeah, that's the one. Yeah. So
Yeah.
that book was the one that got me super into space, and
Yeah.
I really need to get a copy. Feeling kind of nostalgic, but and for me, absolutely. And then going through that and learning sort of the cool parts about space, and then as a teenager, I got my own telescope and started to really learn the night sky. So it's that, it's that process of learning the night sky that I think made me into the astronomy nerd that I am today. So do you find that is like a lost art? How do people take that next level and actually get into knowing the night sky?
Well, the easiest way is to buy Astronomy for Kids, available on Amazon. Sorry.
No, I understand. It's mandate. I believe we require you to do this at least 3 times per show. So.
Yeah, and it's publisher requirement. I the I think there are a lot of ways. The great thing is now with the internet, that wild internet, you can either do things like books like mine or like yours or others out there, or you can look things up online and get excited by the stories from places like the Planetary Society and Universe Today, or you can go to a lot of great websites that give you star information for what's up in the night sky, or planetary radio, or any number of other things. Because I also think the combination of the two, the night sky plus the pretty pictures, which is what I've tried to do, because we've got pretty pictures mixed in with the night sky, and I know you've got some unique amateur astronomer pictures in your book, and then combining that with the night sky information is what really helps.
And I always love to get everyone's advice on a first telescope. What do you think is the best way to start, like actually getting some gear to do some observing?
I'm inclined to go with one of the main kind of standard brands, and there are various, but the Celestron, the Meads, the Orions, there are others, rather than what I got as a kid, which I still have, which is the Kmart Special.
Yeah, I have my version. Had my version of that as well.
And it was pretty good, but obviously you get a higher quality with others. And then the other key, I think, that isn't necessarily obvious is getting something that's easy to set up and use. So if you get into amateur astronomy, then you want the big giant telescope and you want the big giant equatorial motor drive. But just having something that you can pop out of the house and put in the backyard and set up in 5 minutes and actually start seeing something, to me, is more likely to get people into it and less likely to frustrate them and end up being a closet decoration rather than something you use.
So, Jobsonian over, something with a go-to drive.
I can see either way. That's why my brain froze for a moment.
Yeah, no,
there.
I know what you mean.
It's 6 one, half dozen the other. The Dobsonian allows you to do that quick setup and get nice views with a big aperture. But and so I like that, but I also am drawn to enabling, if you have a go-to and you have something else, you can move into astrophotography in easier ways than you can with a Dobsonian. So there's my definitive, non-definitive answer.
Right. All right. Well, let's move on. We'll bring it back around, I promise. But I want to talk about light sails. Obviously, the whole concept of solar sails were brought into everyone's sort of minds over the last couple of months with all of this Oumuamua solar sail controversy. But I'm trying to remind people that there's a dedicated group of people out there that are working on an actual solar sail right now, and it's real. How is the Planetary Society spacecraft doing?
It's doing well. So we've light sails, solar sails use solar pressure. So light's pushing on us right now, but it's a little tiny bit. But you put a small spacecraft, big shiny sail, then you get a push. And we flew LightSail 1 in 2015, which was low enough in orbit we knew it would be dragged down by the atmosphere, but we could test the deployment in the computer, and we learned a lot and had an mission that was way too exciting. And now we've done LightSail 2, which will be fully capable of doing the rotations in Earth orbit required to demonstrate that we're really doing controlled solar sailing. This would be the first time for such a small spacecraft using a so-called CubeSat. It's about the size of a loaf of bread, but the sail that opens up is about the size of a boxing ring. And so we're actually have a high efficiency, but it's been tricky to cram everything into a little tiny box. And so we've also done a lot of ground testing, and right now we're at the point where our spacecraft is ready. It's been ready for a few months, and we're on Falcon Heavy flight. We think the next flight of the Falcon Heavy that continues to slip. So we basically have our spacecraft in storage, and we charge the batteries every couple months and continue to do dry runs of operations and things like that. But right now we're waiting for a Falcon Heavy launch as part of the Air Force SDP-2 payload.
And this is sort of a deeper question. Why are there not more solar sail projects out there? I know the Japanese did the Icaros mission, and NASA has worked a bit on solar sails, but really, you guys with the Planetary Society, you're really the team putting this technology the farthest into development right now, which has got to be difficult to, as not a government agency that is trying to raise money from its membership to do what sounds like a really important kind of propulsion system. We look at what happened with the Kepler spacecraft. It was able to really be saved thanks to understanding how light pressure works and how you could balance the spacecraft while light is streaming from the sun. And it feels like this is there should be solar sails on everything that you could use them for all kinds of purposes.
Think so.
Yeah. Why do you think that solar sails have not been taken as seriously as as you are, and I think a lot of us think they should be, why is it still taking so long?
Well, it's speculation at some level on my part, but I think it's the challenge of it's really is a new way of doing business, and you have to deal with deployable structures, which always makes people nervous in spacecraft, since there's one more thing to go wrong, and then you have to have a attitude control system that's able to work with this type of system. But I'm not sure. My best guess is the intimidating aspect of deployable structures. But obviously, you get the advantage once you're deployed. Then you don't need fuel, and so you have a
Yeah.
tremendous amount of flexibility.
And I mean, I know that one was considered to be attached to the Deep Space Gateway, as I think the Canadians are actually proposing to build a solar sail for the Deep Space Gateway for just making minor course corrections and managing your orbit. But I can think of a lot of spacecraft which failed or didn't get high enough into their altitude, or ran out of fuel, or ran out of various things that just a solar sail would have helped them out if they could have had it on board and positioned it and used it to move them around. So it seems really strange to me that this technology has just taken so long, and I'm so glad the Planetary Society is willing to step up and push this research to the next level. I mean, it feels like this is something that you guys really believe in, and I wonder where that comes from.
Um, I mean, yeah, we do believe in it, and we're trying to fill the niche to demonstrate it. So, I mean, it's like any spacecraft technology. Someone's got to try it the first few times before others are going to start using it in an operational sense. For the Planetary Society, it came out of our executive director emeritus, Lou Friedman, worked on solar sail concepts at JPL for Halley's Comet before joining the Planetary Society. And so that kind of started the push, and then it's continued since then. We tried to fly the first solar sail mission in 2005, Cosmos 1, on a Russian launch that failed. And so then the Japanese successfully flew Icaros, which was quite the triumph, but a large, well, medium-sized spacecraft, 300-kilogram spacecraft, and not as efficient, because basically your efficiency goes up with more area of your sail and goes up with smaller mass. And so we were looking at it to try to make something new and facilitate interplanetary work with small CubeSats, which now are all over the place in low Earth orbit, from universities, from agencies, but they are lacking in interplanetary type propulsion. So we thought, if you don't have to take the fuel with you, that's quite an advantage. Now, how the heck do we fold up a sail and shove it into a little tiny box?
That's the challenge. And there's one other really important mission that you guys are dedicated to, which is to getting a microphone on Mars.
Yes, we've been trying that for a long time.
When's that going to happen?
That looks like it's finally going to happen in 2020 on Mars 2020 rover. There are two microphones that we are connected to, but not behind either of them. And there's one that is supposed to fly in the SuperCam instrument, the instrument that's on the mast of the rover that zaps rocks and vaporizes them. And they're planning on flying a microphone that will not only get public outreach, but they also can do some science with it based on basically how loud the sound is when they shoot the laser and it ionizes the rock. It makes a popping sound, and that ties to the volume of material. So anyway, there's also NASA has decided to put microphones and cameras on, or a microphone on the entry, descent, and landing. So that should sound like that's the wind noise, but then they will have deployments, and then that'll be on the surface. So hopefully, after trying since we flew Mars the failed Mars polar lander flew a microphone in '98. We've been trying ever since on everything that goes to Mars, and it looks like literally.
Yeah, I know, and I know I've written a bunch of stories where it's like, once again, Planetary Society is trying to get a microphone to get to the surface of Mars. Wouldn't you like to know what Mars sounds like? I'd like to know what Mars sounds like.
and it just adds a second sense. So far
Yeah.
and it ties to our vision sense. We see the beautiful pictures, but being able to hear the rover crunching on the rocks
Yeah.
and hear the wind and maybe even the dust blowing and maybe lightning, it would be exciting for exploration. So we've always been able to sell it for public outreach, public interest. But the problem is all the missions, well, it's not a problem usually, but in this case, all the missions are driven by science. So if you can't promise first order or significance of science, then it makes it eventually, no matter how much we've spent months sometimes in consideration and doing engineering studies, but eventually project managers like, I know it's only 50 grams, 50 milliwatts, and a tiny bit of data, but we just can't deal with one more thing.
Right.
And
Right.
so
It's the
that's
integration. Yeah. Well, so we're running out of time, but Bruce, you are a regular contributor on Planetary Radio, which is the Planetary Society's excellent podcast. I've mentioned this before. I really enjoy the Planetary Radio hosted by Matt Kaplan, but you're regularly there, and that's when you get to hear him say random space fact. But I also really enjoy the policy edition. I've learned more about U.S. space policy from that podcast as well. So kudos to everyone on your team making your podcasts. One last pitch again, and where can people find out more?
about.
Well, so let's start with the book.
Okay. Find out more at the book at either at my website, randomspacefact.com, or
I didn't realize that's your website. That's awesome.
it's kind of a it's kind of a lame website right now, but but it has content and it has links, and so it's also available on Amazon if you search Astronomy for Kids. And there's a lot of information before you actually have to buy it to figure out what's in there. But we've got a little of everything, and hopefully we'll get kids excited about space.
Perfect. Well, Bruce, thank you so much for taking the time to talk with us today. Really appreciate it. Congratulations on the book, and congratulations on the LightSail. I cannot wait for it to launch, and all the other work that you guys do at the Planetary Society. So thank you so much.
And I should mention, for following LightSail or Planetary Radio, you can find those at planetary.org.
Awesome.
Thank you so much for having me on.
All right.
Really enjoyed it.
All right.
Take
Thanks
care.
a lot.
Bye-bye.
All right, so let's move on. This week, I randomly choose Kimberly.
Hey.
Are you ready?
I'm ready.
Okay.
Yes. So instead of talking about exoplanets this week, which I'm sure we'll get to later, I want to talk about the upcoming landing of Mars InSight. Yay!
When's that happening?
That's happening on Monday, November 26th, just after American Thanksgiving. And we've been waiting since this lander launched in May for it to make the journey to Mars. And it is finally there, almost there, 5 days away. Almost there, unless you're listening to this on Monday evening, and then it's there. But this lander is going to, hopefully, crossing our fingers, very gently enter Mars's atmosphere, land using a combination of parachutes and rocket boosters underneath the craft, land gently in a region called Elysium Planitia, which is a very well explored area. Gonna land. It's gonna survey around, look around a bit, and try and find a good spot to settle in, because once it deploys all of its science instruments about 3 months after landing, it's done. It's not moving anymore. It's going to stay right there in that spot, and it needs that in order to get very ultra precise seismic measurements of Mars, to measure its the inherent tectonics and seismicity of the planet, Mars quakes, if you will, and also meteorite impacts. And it needs to be ultra stable, ultra still in order to do that. So once it finds its spot, it's not moving no more. And InSight's also going to be doing some other probes of the interior of the planet, measuring the heat flow or the heat transport from inside the planet as well, and trying to figure out what the interior structure of Mars is really like.
I think one of the most exciting things about this mission is the probe that it's going to be deploying, like well, like 5 meters below the surface of
Yeah,
Mars. It's going to be
it'll be the first time we're actually directly exploring the interior of another planet. It's going to be drilling as far down as we've ever gone on the surface of another world, and it's going to be measuring a lot of the internal, sort of like shakes and shudders, and how the heat's moving inside, and get direct measurements of those things, which previously we've only been able to do either from the surface or remotely.
So, what is the big question that InSight is going to help us answer?
It's really going to help us figure out how rocky planets form and how Mars might be different from Earth. Because one of the issues with studying the interior of Earth and how it's evolved over its history is that Earth changes. It has plate tectonics that radically change the surface and also completely alter the interior. So if we really wanted to like drill down into the center of the Earth, if we could do that, if we could drill down into the center of the Earth to try and figure out what Earth was like ages ago, we couldn't do that because Earth has radically changed in 4.5 billion years. Now, Mars's surface has undergone some tectonics, but interior, inside the planet, we think that everything pretty much shut down not too long after the planet itself formed. And so if we can figure out what's going on inside the planet, we can see what conditions were like right when it formed and learn a lot more about rocky planet formation in our solar system and for other solar systems as well.
Yeah, I mean, I guess that's the thing is we've never had a chance to look inside any other planet. So we just know the Earth, and we know about how much of the Earth is solid, is the core, and how much of it is the mantle, and how much of it is the crust. But then to compare that to what Mars is in the structure. And I think, one of the big questions is why does Earth still have a magnetosphere? Why does it still have, a core that is rotating and causing this dynamo, but this doesn't exist at all on Mars?
Yeah,
When
and
did
so
that
one
happen?
of the great measurements that InSight is going to do is it's going to help pinpoint how Mars is precessing on its rotational axis and get a really good handle of its gravity. And what that'll do is it'll help us understand essentially what proportions are like inside the planet. How much of it is core, how much of it is mantle, how much of it is crust. Because we have a good, like you said, we have a good handle of that for Earth. Mars, not so much.
And this is going to be like the 7 minutes of terror that they went through with Curiosity. So it's going to be a very similar landing, powered landing. It's going to have to detach from its aeroshell parachute and do a powered thrust to land. And it's going to...
And we can't do anything about it. Once it starts, it has 7 minutes to do its thing.
Yeah, well,
and then we'll find out if it landed safely.
however many
There is
minutes
a cool part.
longer it takes.
There's a cool part, though, to this one that is different than any other Mars mission, and that's Marco.
Yeah,
So Marco is this
Marco.
pair of CubeSats that has been flying alongside the spacecraft for the whole trip. And as InSight lands on Mars, Marco, for the first time, is going to offer a real-time communications link back to Earth, so that we're getting that Mars telemetry, that InSight telemetry as it's going down. And that's like sort of useful in the sense that if InSight crashes, we'll have a better idea of what's happening. But really the key here is just proving that CubeSats can work and survive deep space, go to another planet and carry out useful tasks. And if that's true, it opens up this whole new world of exploring the solar system for 10 or 100 times less than it costs to build a mission like InSight. And so, even if InSight lands perfectly and Marco just says, yep, did its thing, that ability to survive 6 months in space, communicate with another spacecraft, radio back to Earth is huge.
Yeah.
And in some ways, that's the most exciting part of Monday. I mean, we all want InSight to land, but it's a mission like many other missions have been in the past. Marco is brand new.
And I had sort of this all backwards. So in the past, I was thinking that they had sent Marco and the other CubeSat because they have other infrastructure at Mars and they can communicate. But it's the reverse. Marco is going to serve as the communications relay for InSight. And so to the fact that you can package up all the parts of an interplanetary spacecraft in this CubeSat size and have the ability to be able to transmit back to Earth is, as you said, an incredibly exciting development. You can imagine small spacecraft like this sent to the asteroid belt, to to Mars, to Venus, to Mercury, all these places that are relatively close, that are maybe we haven't explored as well as we could, and get tons of data back for a fraction of the price of what it's going to cost for some of these big flagship missions. So I totally agree. I think it's a game changer. Right on. So Monday, I don't know, are we going to do anything? Should we do anything?
Well, I think if we all show up on next Wednesday,
Yeah.
we'll all either have like really happy faces or really
Right.
sad faces
Yeah.
after Insight lands or not. Morgan, did you knock on wood after you say if Insight crashes? Did you knock on wood? Like run through 7 times around your house? You didn't like jinx
Throw
it,
the
did
salt
you?
over your shoulder.
Should throw it over your shoulder.
Yeah.
I'll do my best.
Pet a black cat or something. That's how that works, right?
All right, let's move on. Paul Sutter, tell me about the Type 1c supernova.
Yeah, speaking of game changers here, so there's a kind of supernova called, totally unhelpfully, Type 1c, which is just absolutely meaningless to most people. Type 1c is a particular kind of supernova that appears to lack hydrogen and helium, which is surprising because just about everything in the universe is made of hydrogen and helium. So we have examples of stars, which are usually mostly hydrogen and helium, blowing up and not having a lot of hydrogen and helium. So the question is, what's going on? And we've suspected for a while. Theorists have not been idle in the past decades, ever since we discovered these kinds of supernova, and they have come up with some models, some possible what we call progenitors, or the stars that lead into a supernova. And for the first time, we may have an observed candidate progenitor. So we recently saw in 2017 a Type 1c supernova go off in another galaxy. And 2 independent teams of astronomers went back through Hubble archival data using the pinpointed location, seeing if, hey, have we taken a picture of this spot in space before? And we have, and there was some stuff there, and we think this stuff led to the supernova. We're not quite sure, because it's in another galaxy, what the stuff is. It might be a single star, it might be a binary star, it might be a star that's a member of a cluster. We're not quite sure. So what we have to do, the supernova went off a year ago. It's still really bright. We have to wait a few more years for that supernova to cool off, and we can take a brand new picture of the exact same spot and double check our results.
So just, I'm trying to understand this process that's going on that's causing this thing. What makes it different? I mean, we know that the Type 1a is where you get a white dwarf that's gobbling up material from a companion, and then it detonates. The type, and then some of the Type 2 supernova, those are the ones that just core collapse and then they just go off.
Right,
so this
right.
Type 1c is, so, and some other kind of strange exotic thing that's happening?
Right. It's actually what we think. And I'm stressing we think. This is based on models and what few observations we have. We think a Type 1c is more like a Type 2 than a Type 1, because nobody understands.
That seems like a failure in naming, right?
Yeah,
there.
someone needs to go back and restructure.
What happens.
Welcome to astronomy.
Yeah, this is what happens when we name things 100 years ago, and the names just stick before we actually understand what's going on. So everyone can thank Fritz Zwicky for the
Thanks,
supernova
Wiki.
Yeah, thanks,
naming
Wiki.
scheme. Thanks for the help, dude. And what we think is going on, there's 2 possible scenarios that lead to a Type 1c. One is you have a giant star. We're talking 30, 40, 50 times more massive than the sun. And towards the very end of its life, it's fusing heavier and heavier elements, and it builds like a big nuclear onion, where it's fusing really heavy stuff like magnesium and silicon in its core. And then in the middle layers, it's fusing things like carbon and oxygen. And then its outermost layers, it's fusing things like hydrogen and helium. And because that process is so violent and so intense, that outermost skin of the onion gets blown off in a phase of the star's life known as Wolf-Rayet. as named after two French astronomers who first discovered this kind of star. It gets blown off, but even though all that stuff is ejected from the star, there's still enough stuff left to trigger a core collapse supernova. The thing goes boom, but there's no more hydrogen and helium. That's one scenario. Another scenario is where you have a binary star. You have one big fat star with like 30, 40 solar masses, and then another not quite as fat, but also significantly large of like 20 or 30. They're orbiting each other. The smaller one sucks up off all that material, all the outer layers onto itself, leaves a core behind. But again, that core is big enough to trigger core collapse supernova, but there's no more hydrogen and helium, and it goes boom, and it gets tagged as a type 1c.
Right. But the point being, these things are very rare.
These are incredibly rare. They're rare because it only happens to the most massive stars. Ironically, they're not too bright because they've lost a lot of their mass. And this particular one that the astronomers noticed just happened to be relatively close, happened to be brighter than average, which gave us the opportunity to look back through the archival data to see the progenitor and what we think is going on. The astronomers fit models of, okay, if it's a single star leading to this one event, then it had this mass. If it was binary stars, then they had these masses. But we need to wait for that supernova to cool off before we can get some more observations.
Very, very cool. Morgan.
Mars. It's going to be awesome. We're landing there next week, but we're also going to be landing there in 2021 with the cleverly named Mars 2020 rover. And I wrote about InSight this week, and I described its landing site as literally the most boring place on Mars. And
on purpose, yeah.
Potential landing site on purpose, but the potential landing site for Mars 2020 couldn't be the more opposite of that. This is one of the coolest, most amazing places on Mars. It's called Jezero Crater, and it's just a little bit north of the equator on Mars. And what's so cool about Jezero is that it's the site of an ancient river delta. And that's just awesome. And it's awesome for like sort of two kind of complementary reasons. One is that sort of by nature, rivers are wet. And so if we're looking for evidence...
Whoa.
I know. This is breaking news.
I got to think about this for a little bit.
If we're looking for evidence of habitable environments on Mars, and we know life on Earth requires water, then a place that we know must have been wet is a great place to go. And that's kind of what Curiosity did when it landed in 2012. What makes Jezero even more interesting is that river deltas are the mouths of rivers, which means that stuff picked up all along the river gets deposited in this one area. And so if you were going to sift the soil on Mars for potential signs of life, there's really no better place to sift than a place where soil from all over Mars that was in contact with water is all piled up. And that's exactly what a river delta is.
So do you know what the word Jezero comes from?
I saw it. I don't remember.
There's a town in Bosnia called Jezero. And if you translate the word in Bosnian, it translates to lake. So it literally is lake crater.
Well, I mean, it was a giant lake, and it is a giant crater.
That's exactly it. Yeah.
Crater lakes.
Got it right.
Yeah.
It's really cool. If you look at a satellite image of this crater, you can. The thing is like 45 kilometers across. The delta itself is about 5 kilometers, and you can see the river that flowed into the crater. And then there is a delta. There's 2 inlet rivers. There's a giant outlet river valley. It's very clear that there's a lot of water flow in and out of this crater for many, many years. And there's so many different kinds of minerals and sediment deposits that we've detected there. The geology and the different rock formations there's a wide variety there. There's so much to explore.
Almost as cool as the science that the crater offers is the engineering that it's going to take to land there, because this is going to be a much more challenging place to land, even than the Curiosity landing in 2012. And NASA made sort of two big improvements on the sky crane system to make that possible. One is they just kind of sort of tightened up everything. And so the error ellipse, basically the area around the nominal landing point where it's likely to actually land, is about 50% smaller than it was for Curiosity, which means that they can pick a safe landing spot surrounded by dangerous things much closer than they were able to with Curiosity. But even that probably wasn't enough to make landing here possible. And so they've added this really cool new capability that basically works like a self-driving car while sky craning down on the Mars surface. So they're going to make a map of this area using the HiRISE camera on Mars Reconnaissance Orbiter. It'll be this detailed elevation map as well as a photographic map. And as the sky crane is descending, it's going to be constantly taking pictures of the surface and comparing those to pictures from this kind of master map. And that will help it sort of understand where it is. And if it sort of detects an area that seems unsafe, it can reroute itself to an area that seems safer in real time during this,
Wow.
8 minutes of terror.
Yeah.
It's kind of like an automatic version of what Neil Armstrong had to do when their Apollo 11 was landing. So they were going down, and where they were supposed to land was bad. And so he took over and landed somewhere flat. This is a robot doing that while hurtling down towards the Mars surface, completely cut off from Earth contact.
People say that self-driving cars are.
Yeah, if you thought the sky crane was crazy, this is like, another order of magnitude on top of that. But it's the only thing that makes it even possible to think about landing at Jezero.
I mean, I know for the last couple of weeks, the various planetary scientists that were involved in this were coming together and arguing about destinations that they should put down with 2020. It must have been, do you think it was a tough decision, or was this just an obvious place to go?
I mean, kind of think about if you only every 5 years you could pick one sort of square kilometer place on Earth to land. There would be a huge list of interesting places to land. And in fact, this particular place is going to be so challenging that although they've announced it as the landing spot, that's contingent on a much greater level of testing on this new automated landing system in 2019. And if the landing system with the cameras doesn't seem to be working as well as sort of the initial tests say it is, they'll have a backup spot that they haven't announced that they can go that is easier and safer. And I think that spot will be, every bit as cool as this, just cool in a very different way.
Yeah.
But will it have a delta?
It will not probably have a delta, which is why we're going to go here.
I want my delta.
Yeah. Oh, this is so exciting. I can't wait. I mean, Curiosity was such an amazing mission. I mean, it's still going, but just that whole concept of the way that the landing system worked, it was so tense when it actually was all happening, and then it was down on the surface, and you just couldn't believe the capability of and size of spacecraft that was now roaming around on the surface of Mars, and now we get another one. I can't wait.
And Mars 2020 is going to do so much cool stuff. It's going to have the microphone on Mars. It might have that helicopter on Mars. They're going to try to grow plants in a tiny little terrarium.
It's going to make
plus
oxygen.
All the science instruments.
They're going to do drilling and collect samples
Elon
that might
Musk
eventually
is
come
gonna
back.
move a boring company to Mars.
Yeah.
Bleh.
All right. Next up, me. So astronomers have found, there we go, one of the sibling stars that formed with the sun from our solar nebula. So if you roll back the clock in the solar system, before the sun was here, there was just this vast cloud of gas and dust, of material left over from the Big Bang, and it was seeded with additional elements from, now we know, colliding neutron stars and nearby supernovae, and that created a very specific chemical signature of the entire solar nebula. And so over time, perhaps there were 1,000 stars. When you look at, say, the Orion Nebula, there's about 1,000 stars forming in there. Pleiades has about 1,000 stars. So it seems the Hyades cluster, they all seem to have sort of this rough number. And so at some point in the ancient past, all of the heaviest stars detonated as supernova. The ones that were left, their solar winds got going and they blasted out all of the material from around them, and then they drifted apart because of all of the chaotic chaotic gravity that was going on in the Milky Way until they were lost to each other. And so astronomers have been trying to find the stars that formed with the sun in the Milky Way. And so there's kind of a couple of techniques to be able to do this. One is to examine the chemical characteristics of the stars. And so you're looking for a star that has the same kinds of chemicals, the spectra, in its outer atmosphere. That'll tell you, you're looking for a fingerprint of essentially something that's very similar. And there's some fairly rare elements in our sun's atmosphere that they've been able to find, yttrium and barium, in one other star, and this was found a couple of years ago in 2014. And after that star was found, astronomers have been still trying to look, but this other star that was found was a little larger, a little hotter, so not really a perfect twin of the sun, but it did have very similar chemicals in it. And so just this week, astronomers announced they'd found a much better stellar twin. They sort of did what I mentioned. They used this one survey, and I'm trying to remember the name of it. Amber. I think it's Amber, A-M-B-R-E, or Ombre, but I think it's Amber, the way we say meter. So the Amber survey looks at, it was a collaboration between the European Southern Observatory and some French observatories to catalog the spectra of about 350 stars in a really close area around us. And then they matched that with the gigantic data release coming out of Gaia, looking at stars in our neighborhood that had the kind of velocity and the kind of trajectory that would originate with the sun billions of years ago. And they found one star, and it is a perfect match to the sun. It's the same size, it's the same chemical signature, and its trajectory is a place that you could get from where the sun would have formed a long time ago. And so the star is called HD 186302, and it's located 184 light years from Earth in the constellation of Pavo. So this is really exciting.
Peacock.
Yeah, the Peacock, yeah. And so this is really exciting, right? Because you've now got what seems pretty certainly a twin of the sun. And so they're going to now take a lot of the powerful telescopes on Earth and direct them at this one star. Because the question is, does the shape of the solar system, the number of planets, the consistency, the kinds of moons and rings and things that we have here in the solar system, is that what you get when you put in those original ingredients into a star? Or is there more randomness that's involved? And so when they study this other star, are they going to be able to find similar planets and constituents in it? And it's a way to start to really figure out. It's like twin studies here on Earth. It's a great way to find out more about human beings by having twins and figure out what's the same about them, and if they go through different lives, what's different about them. So I suspect this is going to become one of the most observed stars for a long time. And
Hey, Fraser.
yep,
I have a snarky and irrelevant question. Are we the evil twin
Right.
sun, or
Yes.
is the other star the evil one?
it just all depends on the beard.
Okay, yeah.
Yeah. But I mean, like right now, look at us right now on the camera here. Like we are absolutely from the evil side.
It
So,
is
evil
true.
solar
Hey.
system. Just the
Speak for
ones who are
yourself.
on the camera right now. I guess you and Morgan are
Ethan
from the
Siegel
good
on his
universe.
podcast introduced me as the Ethan Siegel from an alternate timeline.
Huh. Alrighty.
From the evil universe.
I have to
Well,
say,
he
I
didn't say. He
don't
didn't say
quite
which one
see the
was it.
resemblance.
Which timeline?
But
Yeah.
It's an alternate timeline.
Yeah.
Just generally vague, bald bearded guy
Right.
in
I
his
see.
30s who's an astrophysicist.
Yeah.
do you wear a kilt?
One of the things that I find great about this discovery
Pass.
is there's a really powerful new tool that is on the Very Large Telescope for the Southern Observatory called Espresso, and it can observe exoplanets directly. So no radial velocity, no transits. It just takes pictures of planets
picture.
going around other
Yeah, I was
stars.
going to ask, are there planets around this star? And if there are, what's the likelihood that life from us accidentally went over there too.
Well, so this is something that they brought up in their press release, and I have been looking to kind of, I've been taught by the masters to not go too deep into this, but one possibility is that, of course, you could have interstellar panspermia, where during the late heavy bombardment, microbes from Earth were smashed into space, and they made the long journey from star to star, and so there's a better chance of finding life there than some other star, say the scientists. Although I'm skeptical. There, how's that, Paul?
You don't just get to do like 99% and then at the end say, "Oh yeah, but I'm skeptical." But
yeah. I just did it.
That doesn't forgive your sins.
Textbook. How to weasel your
Partly
way
my
out.
fault. I did ask.
Yeah,
the
no, I
question.
didn't even bring it
Totally
up.
asked the
But
question.
yes, I'm
That's
glad
true.
you asked. Galactic panspermia. There's got to be life there. All right, moving on.
Laying it down.
Paul, tell us. You've got one last quick story to tell us.
Yeah, this is just a fun thing I found. There's a podcast called the ExoCast, hosted by 3 exoplanetary astronomers, and they're holding a competition, the Exo Cup 2018.
Exo Cup. I love
The
it.
Exo Cup. So you get to vote for your favorite exoplanet, and I'm only mentioning this because the Ohio State University, in a desperate bid for any positive news whatsoever, issued a press release that an exoplanet discovered by our own Scout Gowdy in the Department of Astronomy here, Kelt 9b, is one of the finalists
For the-
Kelt 9b.
For the Exo Cup.
for the
That's a good
Exo
one.
Cup.
Kelt 9b is a good one.
It's a good one, but there's lots of good ones, and I think you can go vote. You vote
Yeah.
on Twitter.
I think you
by
could
following
choose Kelt 9b and PDS 70b are the 2 planets now.
Yep. So we're
There's only
getting
those
close.
2 left.
Yeah.
Aww.
So there's 2 brackets. There's a transiting bracket and a non-transiting bracket.
Now so go and vote. Is what
Yeah,
you're
so
saying.
go and vote. Just go exocast.org or look them up on Twitter and go vote. Have some fun and learn about some of these really, really crazy, interesting exoplanets.
All right, one last quick little topic of conversation here, and my co-hosts don't want to talk about it at all, but I know we have to address it, so I will either just monologue or they can jump in at any point, and that is, of course, Elon Musk threw all of our expectations out the window, announcing that the BFR is having its name changed to Starship. So now it's going to go to other stars, I guess. It's in the name. But also, he said, remember, was it 2 weeks ago we announced that they're planning on building a mini BFS, or I guess mini Starship now for the Falcon 9, and now that's been canceled. But also he says that he's completely redesigning the Starship. I'm never going to get used to this.
Yeah. I have to ask, now that it's a Starship, does that mean that all the astronauts that are going to be launched on SpaceX vehicles are going to be Starship Troopers?
Starship Troopers?
Is that what that is now? Sorry, I had to ask.
Yeah, yes.
great.
Yes is the answer. Yes, they are.
The answer
We
is
have to
yes.
bring up
Thanks.
SpaceX. Maybe we should mention that NASA is launching an investigation into
Yes.
SpaceX based, it seems, solely on Musk's public behavior. And this sort of threatens all existing NASA contracts with SpaceX to be conducted and concluded in the near future.
And I just should say the name Starship does not obligate to visit any stars. The Friendship 7 did not visit any friends. So you can put anything you want in front of the word ship.
Okay, that sounds good.
You don't have to
But
go.
I like are you kidding? There was absolutely friendship on the Friendship 7.
It didn't travel to. It carried the Friendship with it.
So this is going to carry the stars with it?
Yes.
All right.
In
We're
our
all
hearts.
star
In our
stuff.
hearts. All right, fine.
In our
Whatever, Elon, just make spaceships fly and land on their launch pads, and you
Aren't
can
you
call
busy,
them
Elon?
whatever
Don't you have work
like.
to do?
Don't you have a tunnel to drill? Yeah, he's listening right now.
Yes.
We
And I'm
admire
admonishing him.
we admire your work, Elon, and we can't wait to see the Starship fly. And if you make this thing fly, we will call it whatever you want. All right, Paul, I see you on my screen right now. Why don't you tell us all about what you're working on and new things that have happened today?
Well, yesterday was my book birthday, the launch of Your Place in the Universe, Understanding Our Big Messy Existence. It is a fun journey through our universe and our understanding of the universe. It's a love letter to science. It's a really fun book. It was fun to write. I hope it's fun to read. It is in bookstores nationwide. It's available on Amazon, Barnes & Noble, IndieBound, Books A Million, also my website, pmstarter.com/book. And if you've bought it, go leave a review on Amazon. That really helps sales and visibility. I really appreciate it.
Absolutely. Seriously, go leave a review. That's the only way. All right, Morgan, what are you working on?
I've got two cool videos coming out this week. Already out is a video about the 3 most extreme galaxies in the universe. And then coming out this Friday will be one talking about another possible Type 1c progenitor, as well as a little bit more about InSight. You can check those both out over at SciShow Space.
That is awesome. Kimberly.
So I've been spending all my time learning about the Mars 2020 landing site, which I was super excited about. And I'm also learning about how giant dinosaur shark teeth can tell us about the history of the ocean.
Ooh, the Meg.
Yeah, the Meg.
That was playing on
But
the
not the movie,
on the
because that was like
airplane.
weird. But like the actual dinosaur sharks. Yeah.
Yeah, the Meg.
That was weird. Not that.
All right, and of course, what am I doing? I don't know.
What are you up to?
I'm. We just put out a new video like yesterday, all about the Oumuamua controversy. As you can tell from how knowledgeable I am about the solar sibling, we just recorded a video on that, so that's going to come out in a couple of days. So just stay tuned to the YouTube channel. We got lots of good stuff. And if you haven't already, you should really sign up to my newsletter, which I am really enjoying. I'm putting a lot of work into. It's completely different than anything else. So if you want just a nice, just daily or weekly dose of space news, everything you need to know about space and astronomy, sign up to my email newsletter. Just go to universetoday.com/newsletter and sign up. I promise it's the one newsletter you will hang on to while you get rid of the
I
rest.
can vouch for that. It's a very nice newsletter. It's a serious value add to your life.
Perfect. Done. It's good enough for Paul. And of course,
Go down to Astro Tour to Costa Rica.
and well, so right. So Paul, let's just remind everybody about Astro Tours. They've only got about just a little over a month now to reserve before.
Yeah, Costa Rica, it's filling up, and we were able to work with the tour provider to extend the deadline. It's through the end of December. You have to sign up by then before we close the trip. We do have a few spots left, and we'd really love to fill it up and just bring as many friends as possible. So if you're thinking about going on a trip, go to astrotours.co/Costa Rica, and the trip is in March. It's going to be tons of fun.
Yep.
Astro Tours just bought a telescope from OPT.
Oh, good.
That we are going to bring on. We got an 8-inch Smith Cassegrain. It's going to be an awesome scope, and it's just for us and just for you.
Oh, that's perfect. But there's going to be lots of non-space stuff. We've learned our lesson. There's
Yes.
a lot of non-space stuff that we're going to be doing as well. Volcanoes, wildlife, bugs,
Maybe dancing,
sloth,
coffee. There's coffee.
birds, chocolate.
Sloth.
So
Beach.
I feel like you're just saying words now.
Yeah, so you should definitely come and join
It's fun.
us.
So
We're
if
gonna
you
have
have a
lot of fun.
spouse that's not into
exactly.
the spacey stuff, it is a really, really fun adventure for the whole trip.
All right, well, I'm going to wrap things up now. Gallery view, everybody's here. Right on. Thanks, everyone, for joining us this week. Thanks to Bruce for bringing his knowledge. Thanks, as always, to the WSH crew. Thanks, everyone, watching. We will see all of you next week. Goodbye. And...